When working with LLM jobs, tokens are a core concept because they affect context windows, cost, and prompt design. The more tokens you send and generate, the more context the model can use, but the more expensive the job becomes. Understanding that trade-off is an important portfolio skill across LLM engineering, AI product work, and agent systems, because it shapes both performance and practical system design. This matters because models don't actually think in words. They operate in tokens. Tokens are the basic units APIs used to meter usage, enforce limits, and calculate cost across providers like OpenAI, Anthropic, and Google. For hiring teams, that's important because strong candidates can connect token budgets to latency, pricing, and memory. If someone only talks vaguely about prompts, that's usually a warning sign. Here's the roadmap for this session. We'll start with token accounting, how input, output, and cache tokens are measured. Then we'll look at context windows, including capacity limits, and what happens when you exceed them. After that, we'll cover cost architecture and smart caching strategies. We'll also walk through portfolio project ideas that make token trade-offs visible, and finish with an interview playbook for answering both direct and indirect token questions. Concept 1 is token accounting. Every API call is measured in 3 token categories, and each one is priced separately. First, input tokens. That's everything you send in, like the system prompt, conversation history, and the user's message. Second, cached input, which is reused prompt content the system can pull from cache at a lower cost. And third, output tokens, the text the model generates, which are usually the most expensive. Tokenization is what models actually see, not whole words, but smaller subword pieces. Modern tokenizers like BPE, WordPiece, and Unigram break text into vocabulary tokens, so the same sentence can produce different token counts across models. That matters for prompt length, multilingual text, code, punctuation, and cost. The key rule is always measure, don't guess. Using tools like TickToken, Hugging Face Fast Tokenizers, or Anthropic's Token Counting API. Here's a quick comparison of context windows in Concept 2. Claude Standard supports up to 200,000 tokens across Claude 3, Solaris, and Claude Sonnet 4 Standard. Claude Sonnet 4 Beta expands that dramatically to 1 million tokens, available through the Anthropic API, Amazon Bedrock, and Google Vertex AI. By comparison, GPT-4o offers a 128,000 token context window, which is OpenAI's flagship option for most production use cases. A key failure mode to understand is context overflow. If you exceed the context window, newer Claude models don't silently drop tokens. The API returns a validation error. That's a useful implementation detail, and exactly the kind of thing interviewers like to hear. Also, a bigger window doesn't eliminate retrieval. More context gives you more capacity, not better signal. So, chunking, summarization, and smart retrieval still matter, and larger windows also cost more. Concept 3 is token cost architecture. Not all tokens cost the same, and that should shape how you build your system. Output tokens are the most expensive, so avoid generating more than you need. Uncached input tokens are billed at the standard rate, which makes stable prefixes valuable. And cached input tokens are much cheaper, so designing prompts and workflows that reuse shared prefixes can meaningfully reduce costs. Here's how prompt caching works in practice. When you send a prompt, the system checks whether the beginning or prefix matches content it has already cached. If it does, you get a cache hit and pay the lower cached rate for that reused portion. Cache invalidation happens automatically. So the key to better performance is keeping system prompts and tool schemas stable across repeated agent tasks. Here are 3 practical ways to reduce cost. First, engineer for token efficiency by setting max completion tokens and giving clear instructions and examples so responses stay concise. Second, reuse stable prefixes, like consistent system prompts and tool schemas, to improve cache hits across requests. And third, route by complexity. Use lower-cost models for simple classification, and save large context reasoning models for the harder cases. Here's a quick comparison of common system design strategies. Full context prompting is simplest, but token costs get high, so it works best for short documents or early prototypes. Retrieval with chunking scales better for large corpora and QA. Retrieval plus summarization lowers cost for dense documents, but adds complexity. Prompt caching is efficient for repeated agent tasks, and model routing gives the lowest overall cost for mixed workloads, though it's the most complex to implement. For Portfolio Project 1, I compared 3 document Q&A strategies side by side. Strategy A is naive, full context prompting, which gives us a baseline for cost and latency. Strategy B adds retrieval with chunking to reduce token usage. Strategy C combines retrieval and summarization, which drives tokens even lower, but takes more engineering effort. By showing token counts, latency, and cost per query together, the trade-offs become clear and measurable. This project shows an agent workflow optimized with prompt caching. On a cold start, we send the full system prompt and tool schema once. Then we cache that stable prefix, so future tasks can reuse it, instead of resending the same tokens. With a warm cache, repeated agent calls become more efficient. The key result is a clear before and after comparison of token usage and cost using Anthropic or OpenAI caching APIs. Portfolio Project 3 is a model router that uses token awareness to decide where each task should go before sending a request. It estimates token count and combines that with task complexity, not just content type. Short, simple prompts go to a cheaper, faster model, while longer context or heavier reasoning goes to a more capable one. The system also logs cost by route, using token counting from Anthropic, Gemini, and OpenAI's tick token for pre-flight estimates. Here are a few direct token questions that often come up in interviews. Be ready to explain the difference between input tokens, which are what you send to the model, and output tokens, which are what it generates back. You should also know how to estimate token usage ahead of time. What happens if a prompt goes past the context window, and practical ways to reduce token cost in a production system. A lot of LLM interview questions are really system design questions in disguise. If they ask about long manuals, huge PDF collections, or conversation memory, don't just describe the model. Talk about token counting, pre-flight checks, context limits, truncation strategy, retrieval versus summarization, and where caching helps. Also, mention output limits, failure modes, latency, and cost. That shows operational maturity, which is usually what the interviewer is actually testing. Hiring teams usually look for 4 practical skills here. First, can you measure token usage before and after prompt changes? Second, can you design prompts and workflows that stay within context limits? Third, can you optimize for lower cost without hurting quality? And finally, can you clearly explain the trade-offs between using longer context, retrieval, caching, and tighter output control? Here's a practical career strategy. Treat tokens like a real product concept, not just background theory. Learn one tokenizer well, and use tools like Tick Token or Hugging Face to inspect token counts yourself. Learn one provider's pricing page deeply enough to explain input, output, and cached token costs out loud. And in your own projects, make token counts a first-class metric right alongside accuracy and latency. Tokens are really the accounting layer for LLMs. They determine cost because billing is based on tokens, capacity because tokens are what fit into context, caching because reused tokens can be much cheaper, and output because token limits shape how much you can safely ask the model to generate. People who understand tokens this way can better manage user experience, infrastructure spend, and overall model reliability. Here are the key takeaways. First, measure before you build. Use pre-flight token counting, so token limits or costs don't surprise you at runtime. Second, design for token efficiency from the start. Things like caching, model routing, retrieval strategy, and output limits are core engineering choices. And finally, make this visible in your portfolio. Show token counts, cost per query, and the trade-offs you made, because clear numbers are much stronger than vague claims.